Hello everyone, welcome to ANR Academy. This is Nepal Reddy sir. Today we are going to discuss greatest integer value based questions from the topic Binomial Theorem. See here the statements. If suppose p plus root q whole power n, that is equal to integral part plus fractional part, and p minus root q whole power n is another fractional part. Mentioned here I integer, f dash are fractional values, and small n is belongs to n. Then you have to remember that the combination of different fractional part values become 1. Next, another one, second result it is, if you have root p plus q whole power 2n plus 1 equal to I plus f, and root p minus q value whole power ikkada 2 power n plus 1 undali. If it is equal to another fractional part, then you have to remember that f minus f dash becomes 0. First result ki second result ki difference enti ante ikkada exponent you have 2 power n plus 1, that is odd number. In the first one you have natural number. So integral value based question, particularly from the topic binomial theorem, we are going to discuss now. And the application question, let us see here. Find the greatest integer value of root 2 plus 1 whole power 7 is there. First we will discuss the concepts and we go for the application question. See here, I plus f is p plus root q whole power n is there. Therefore, I plus f p plus root q whole power n implies, with the help of binomial expansion, it can be written as nc0 p power n plus nc1 p power n minus 1 and then root q power 1. After that nc2 p power n minus 2. Next what we get? Root q whole square plus and so on up to the last term ncn. Here I am going to mention ncn root q whole power n. Next, f dash is given as p minus root q whole to the power of n. P minus root q whole power n if suppose only the fractional part. I am going to expand with the help of binomial theorem. nc0 p power n, alternate with plus minus sign, you will get the result. Here nc1 p power n minus 1 root q, after that plus nc2 p power n minus 2 root q whole square and then minus sign and so on. Last term minus 1 power n ncn root q whole power n. These are the two results after expansion. Now what I am doing, observe. Here the aim is to find f plus f dash result 1. So that I am going to add these two. When you add these two, suppose adding these two, what we get, observe. When you add these two, it become I plus f plus f dash, that is equal to, and here on addition second term fourth term, like that the terms will get cancelled and we get 2 times of nc0 p power n, and after that 2 times of nc2 p power n minus 2 root q whole square value simply q, and so on. So that it is very clear that nc0, nc2, nc4 and so on, they are binomial coefficients, they are integer values, and p power n minus 2 as well as q in the next step q square, they are also integer quantities. 2 multiplied by integer, here there is no square root of q, there is no irrational quantity in the right side, so that it is pure integer quantity, implies 2 multiple I can write, and it is clearly even integer. Yes, but the aim is to find the value of f plus f dash in this case. You know that f is fractional part. Fractional part value always lies between, in between 0 to 1. I am going to write f value fractional part, that is between 0 to 1. 0 also included, but here to get the fractional part value I am not going to select 0. If fractional part is 0, then it is pure integer quantity, but fractional part non-zero quantity, so that f value I am going to write 0 to 1, and also f dash also fractional part in between 0 to 1 only. Now adding these two, f plus f dash, maximum value here we get 2, and minimum value here we get 0 plus 0, that is 0. Minimum values of f dash 0 0, so that minimum quantity 0. Maximum values of f dash 1 1, so that right side it is 2. In between them you will get the values of f and f dash. Yes, now here observe I value integer quantity, and f plus f dash also integer, then only you will get even integer. I value here 2 multiple gives even integer quantity. Integer plus integer only gives integer quantity. So that from this I can write f plus f dash also an integer. And here f plus f dash value in between 0 to 2. In between 0 to 2 integer only 1. So that here the conclusion I am going to write, therefore the integer quantity in between 0 to 2 I am writing, that is f plus f dash equal to 1. So this is the first result, f plus f dash value become 1. Let us move to the second result. See the statement, root p plus q whole power 2n plus 1 is I plus f, and root p minus q whole power 2n plus 1 is f dash. Then the result is its difference become 0. Let us see. Here first I am going to write the value of I plus f. I plus f is root p plus q whole to the power of 2n plus 1. Next f dash, that is root p minus q whole power 2n plus 1. With the help of binomial theorem I can expand this. This is 2n plus 1 c0. Next root p power 2n plus 1 and q power 0. Second term 2n plus 1 c1 root p power 2n q power 1 plus 2n plus 1 c2 root p power 2n minus 1 q power 2 plus and so on. The last term 2n plus 1 c 2n plus 1 and q power 2n plus 1. When you have negative sign here, we get alternate plus minus sign. So that here I am writing 2n plus 1 c0 root p power 2n plus 1 q power 0 plus 2n plus 1 c1 root p power 2n q power 1. Here it is with negative sign, right? Yes. Next you have to write plus sign. 2n plus 1 c2 root p power 2n minus 1 q power 2. Next minus sign and so on plus minus 1 power 2n plus 1 2n plus 1 c 2n plus 1 q power 2n plus 1 it is. Now to find difference between f and f dash, f dash difference is our aim, so that subtracting these two results what we get, observe. Yes, now we are going to subtract this. On subtraction what we get, I plus f minus f dash. సబ్ట్రాక్షన్లో మీకు ఇక్కడ సింబల్ చేంజ్ అవుతుంది కదా, ఇక్కడ సింబల్ చేంజ్ అవుతుంది, ఇక్కడ సింబల్ చేంజ్ అవుతుంది, అవునా? ఇక్కడ సింబల్ చేంజ్ అవుతుంది అంటే మీకు ఫస్ట్ టర్మ్ థర్డ్ టర్మ్ అలా క్యాన్సిల్ అవుతూ పోతాయి. అండ్ వాట్ వి గెట్ 2 times ఆఫ్ 2n plus 1 c1. ఇక్కడ రూట్ p పవర్ ఈవెన్ నెంబర్ వస్తుంది కదా, రూట్ p పవర్ 2n తర్వాత q. నెక్స్ట్ టర్మ్ మీరు గెస్ చేస్తే 2n plus 1 c3 రూట్ p పవర్ 2n minus 2 వస్తుంది, q స్క్వేర్ వస్తుంది. ఇలా కంటిన్యూ అవుతూ ఉంటుంది. అగైన్ అబ్జర్వ్ హియర్, ఇక్కడ రూట్ ఓవర్ p is there. root over p whole power 2n, root over p whole power 2n minus 2. They are due to even powers. The term which you have in bracket, that is integer quantity. So that I can write 2 times of m. That is again here it is even integer. Okay. Now since that is integer quantity, now what I am doing, observe. You know that fractional part value actually in between 0 to 1 including 0, but here it is written as integer plus some fractional part. Why? Because here you have irrational number. So this is non-zero quantity in this case. Now f dash also fractional part value in between 0 to 1. Now difference of these two I am going to write f minus f dash lies between. In case if you have f value 0, f dash value maximum 1, you will get minimum minus 1. f 0, f dash suppose that 1. On subtraction 0 minus 1 gives the result minus 1. Next, suppose f is 1, f dash is 0, then the difference at most 1. And here it is an even integer. Integer plus integer quantity only integer. So f minus f dash clearly integer quantity, and that integer in between minus 1 to 1, so that I can write here f minus f dash value, integer in between minus 1 to 1 is clearly 0, so that the result difference between the fractional values become 0. These are the two results you have to remember. These are helpful to solve application problems which you have in binomial theorem, particularly interlinked with greatest integer value of root p plus q whole power n model. Let us see this application question. The question here given that find greatest value of root 2 plus 1 whole power 7. Root 2 plus 1 whole power 7, in that just we need greatest integer value. Yes. To solve this, I am going to use the previous application. Here, first I am going to write root 2 plus 1 whole power 7. Also, I am going to write root 2 minus 1 whole power 7. Observe here, root 2 value 1.414. From that, if you remove 1, it gives 0.414. That is fractional part. Suppose that f dash it is, and it is suppose that I plus f. Now, with the help of binomial theorem, I can write 7c0 root 2 power 7 1 power 0. Next plus 7c1 root 2 whole power 6 1 power 1 plus 7c2 root 2 power 5 1 power 2 plus and so on. I can write the last term 7c7 1 power 7. Next, using binomial theorem, next expansion, this is with alternate plus minus symbols. Here you get minus sign, root 2 whole power 6 1 power 1. Next plus sign 7c2 root 2 power 5 1 square. Next minus sign, and so on. Here the last term gives negative sign, 7c7 into 1 power 7 it is. Now, I am going to subtract. Yes, on subtraction, what we get, observe. Here the exponent is odd number, so that I am going to use the second result. In the second result, this is I plus f minus f dash become, here on subtraction it is minus sign, it is with plus sign, higher minus sign, and so on. We get these two terms gets cancelled, these two also gets cancelled. We get 2 times of 7c1 root 2 whole power 6 1 power 1 1. Next plus 7c3 root 2 whole power 4, and after that we get 7c5 root 2 whole square, and also we get 7c7 root 2 whole power 0. Yes. And we know that in this case f minus f dash is clearly 0, right? F minus f dash value 0, so that here the aim is in root 2 plus 1 whole power 7, we need to find integral value, greatest integer value of root 2 plus 1 whole power 7 is given. Root 2 plus 1 whole power 7 already assumed greatest integer plus fractional part. We need only integral part but not fractional part. So our aim is to find the value of I. You know that f minus f dash In this case 0. Why? Because it is of the form root p plus q whole power odd number, root p minus q whole power odd number. If you have, then you know that f minus f dash is 0. So that automatically you will get the value of I. Now I am going to write the value of I. I is clearly 2 times of 7c1 multiplied by root 2 whole power 6, that is 2 power 3, 8. Next 7c3 root 2 whole power 4 value, that is 4. Next 7c5 root 2 whole square value 2, and after that 7c7. Now you need to write the values of 7c1, 7c3, 7c5, 7c7. You know that 7c1 value, that is 7 into 8. Next plus 7c3 value you have to write 4. 7c5 multiplied by 2. 7c7 value 1 here. I am going to find 7c3, 7c5. 7c3 value 7 factorial by 7 minus 3 factorial into 3 factorial. So 7, 6, 5, 4 factorial gets cancelled, 3 to 1. So that we get 35 here, 7c3. Next 7c5. 7c5 value 7 factorial by 5 factorial into 2 factorial. 7 into 6 divided by 2. That is 21 here. Yes, now the value of I on simplification we get the result 2 times of this is 56. Next 140. After that 42. Next plus 1. Now 140 plus 56 plus 43, that is 239. 239 multiplied by 2 gives the result I value become finally you got 478 is the answer. So these are the applications interlinked with binomial theorem problems along with greatest integer part and fractional part related. So these are 2 applications you have to remember carefully, and they are helpful in JEE examination. Thank you.